So let's go ahead and do another problem, but this one's much more K related because it's going to have a bunch of angles. Eight and 6. There we go. Okay. Okay. Cool. All right. So this one should be pretty easy to figure out, or at least what we're going to do for it. But even if the math's a little tricky. Again, we're going to do x and y. We're just going to add them up in those directions. Okay. So what we're going to do first, we have a bunch of different stuff. You can see we have one straight up, one horizontal, but we have two at angles, one at a 30-degree angle and one at a 70-degree angle. Pardon me. So let's go ahead and get started as best we can. So this 6 is positive, and it's going to end up in this y column over here. This 5 is positive and goes in our x column. Okay. Now we have to figure out the x and y components of each of these two additional vectors. Okay. Let's start with this guy down here. Now, the way we define, say, the cosine of an angle is equal to the adjacent side over the hypotenuse. Okay. Now, if we want to find the length of this adjacent side, we can move this hypotenuse over here by multiplying both sides by the hypotenuse. And we can redefine our equation as the hypotenuse multiplied by the cosine of the angle equals the length of the adjacent side. Okay? That is more or less the definition of these trigonometric identities. Okay? So what that means is, let me clear some of this out of the way, that we can take the hypotenuse multiplied by the cosine of the angle, and that gives us the length of the adjacent side, or the hypotenuse multiplied by the sine of the angle, and that gives us the length of the opposite side. Both of those things are true. Okay, so let's go ahead and use these identities to write in our x and y components for both of those vectors. Okay, so we have on this first one, the length of the hypotenuse is 10, and the cosine of our angle, which is 30. Over here, we would have 10 sine of 30. Now, for our second one over here, we would have 8 multiplied by the cosine of this angle, 70, plus 8 times the sine of this angle, 70. Okay? And now all we got to do is just add these all up. Now, if you want to, you can go ahead and press enter in between each function and just add them up. But what I'm going to do is do it all in one long text string. So 5 plus 10 times the cosine of 30 plus 8 times the cosine of 70. And that gives me a length of this side down here, our A side. So this side right here is equal to 16.396. I just don't like to round, so I try to avoid it as much as I can. Same deal for this one, except we very carefully make sure that we type in all of our right numbers. 6 plus 10 sine of 30 plus 8 sine of 70. And that gives us a y displacement of 18.518. Okay, so we have our A, and we have our B. Same thing as before, A squared plus B squared equals C squared. So, and again, just because I hate rounding, I'm going to do my best to avoid it. So, this squared plus squared equals 611.74. And then if we square root both sides, we end up with a C of 24.73. Actually, let me go ahead and check that. So 16.396 squared plus 18.518 squared both sides. Yeah. Okay. So it's definitely right. I like to check my arithmetic sometimes, but there you go. In just a few moves, we ended up with it. But as is our custom, let's go ahead and again solve for our angle. Okay. So again, if we're solving for this angle right here, B is our opposite side, and A is our adjacent side. So we just have the tangent of the angle equals 18.518 over 16.396. We can punch that into our calculator and then do the antitangent. 18.518 divided by 16.396. Antitangent of both sides. We have a 14.48. 48.48 degrees. There we go. Okay. Angle and magnitude. Feels pretty good. Knock that out. Let's get a good